Everybody, I'm Phil Sadler. I'm the head of the Science Education Department here. And we have a special treat this morning as a part of our seminar series, which we give every month. We bring in distinguished science or math education researchers to talk here at the observatory. We have a special time today because Chris Dede is here to talk to us. Now, I met Chris back at the NSF sometime in the 90s when you were there, and you were thinking about how to teach science and math using technologies, and I think you were a program officer there at the time.
I was a rotator.
Yeah, rotator. So
Yeah.
you were giving money out to people.
I was.
Yeah. But you made me that at that time. But
Yeah. And people paid more attention to me then than they ever have since.
but he has an interesting history, which I'll go back as far as undergraduate days. He went to Caltech and he double majored in chemistry and English. So he is a scientist who can write, which it's almost a non-intersection of two texts. And from there, he got his doctorate in science education at UMass in '72. And since then, he's been working on the forefront of the use of technology in the teaching of science. Now, I know about his research, which is to use, for the last 10 years, to use virtual immersive environments. So he creates these artificially constructed environments and has students work within them. The most interesting part, I think, is that he gives them tools for augmenting social interaction within these environments. So not only they have sort of some powers that they don't have as in their ordinary lives. And the second thing he does in technology, which is really intriguing, is combining these virtual worlds with the real world. So you have tools that you can use in this virtual world that apply to the real world that you exist in. Mainly it's been in terms of ecosystems and ecology, but I think it's broadly applicable in all the areas that we're interested in. I'd also like to know about how this would apply to professional development as well. If you can touch on that, that would be great, since we do a fair amount of assessment of a professional development. So I'd like everyone to welcome Chris Dede from the Harvard Graduate School.
I really appreciate the chance to share ideas, and I know that my colleague Tina Grotzer came some time ago and talked about aspects of this work. I'm going to complement what she said. So she talked about probably one or two projects, and she talked about findings. I'm going to talk across 4 projects and talk about design. So anytime I say I, when I'm talking about those 4 projects, I mean we. We've had a core team that for 9 years across these 4 projects has had a trajectory of thinking about these issues, and it's been absolutely fabulous. But I don't want to start by talking about technology, because then you have a solution looking for a problem, and that is never a good thing. So I want to talk about deeper learning. Now, in 2014, the Hewlett Foundation funded 12 white papers about different aspects of deeper learning. I wrote the one about technology. And the term came from a 2012 National Research Council report called Education for Life and Work in the 21st Century that identified like 19 core skills that students would need in the 21st century across the cognitive, the intrapersonal, and the interpersonal domains. I'm not going to attempt to summarize that today, but you can find out about it in the report, which is online. And toward the end of the report, they had a little bit of material that said, and of course, the way to teach these skills is deeper learning. So what is deeper learning? Well, there isn't a single standard definition. But most people who talk about deeper learning talk about kinds of pedagogy that can create it on this list. Now, those of you who've been around for a while have seen similar lists with different words at the top. So this is yet another, repackaging of old ideas under a new term, but certainly powerful ideas. And one of the things that's characteristic of deeper learning is that it's very difficult to do in classrooms. In fact, some of these aspects are almost non-existent within classroom settings. And that's because classrooms are incredibly barren places. I mean, the least interesting room that anybody spends time in during their day is a classroom. There's a bunch of tables, a teacher bunker up here, chairs of different kinds. Now that people have their own devices, they can get a little more variety. But it's a very difficult place in the middle of winter to talk about ecosystems when there's just nothing in there, maybe a little terrarium or something, or maybe you can show up PBS video, but it's just totally inadequate. So I've been fascinated with immersion as a way of doing situated learning in barren places. Now, immersion is when your mind is in a different place than your body is located. And put that way, it sounds really weird, but we all experience immersion frequently. So I do a lot of travel on airplanes, and I pull out a book of some kind, and I become immersed in the book, and my mind is somewhere else instead of in the cattle car. Or you go to a movie theater, and 5 minutes after the movie starts, you're with Harry Potter at Hogwarts, even though your body happens to be sitting in a crowded movie theater. But those are relatively weak forms of immersion because they're passive. And what I've always been fascinated with is more powerful forms of immersion, where it's interactive and you're actually shaping the thing that you're immersed in. 40 years ago was when I got my first insight about how powerful this could be. Some of you who've really been around for a long time will remember a computer game called Zork, which was simply a text-based computer game with very sparse text, but it was incredibly immersive. And so I began to think about what that might mean. And if you look at the literature on immersion, there's a number of good things that it can do from an educational point of view that reinforce situated learning. So whether it's in the real world, or like an internship or an apprenticeship, or whether it's in a virtual setting, typically immersion is highly engaging because you have a rich environment rather than a barren environment. You develop an identity within the immersed world that may be different than the identity that you have ordinarily, and that's certainly powerful if you want to involve kids in STEM and to get themselves thinking about themselves as powerful in STEM. It's evocative because you can, as you'll see, scaffold a very rich set of behaviors that just aren't possible to get into classrooms otherwise. And the hope is that there's more transfer, because we know that far transfer from the blackboard to the real world is incredibly hard. And if you're in something that's more like the real world, or even is the real world, augmented, then transfer is going to be easier. And finally, in an era of big data, there's lots of interesting kinds of evidence that the evocative nature of these worlds can pull out that helps you to understand through what Val Schut calls stealth assessment, how to help students get better and how to help teachers to help them. So that's the kind of pitch for why immersion is important in terms of thinking about situated learning and transfer, which we know are very powerful because we know about real world things like apprenticeships and internships and other things that fall under that category of deeper learning. So 25 years ago, I did very early work in virtual reality. First thing we did with NSF funding, this is 1992 dollars, is buy a $400,000 used graphics supercomputer that had far less power than today's cell phones. But we did bleeding edge work trying to understand virtual reality, actually in physics. Joe Reddish, for those of you who know him, was our subject matter expert for Maxwell World and for Newton World. Almost 20 years ago, I shifted to working in multi-user virtual environments. Think an interface like World of Warcraft, where now your avatar is what's immersed, but you're immersed through the avatar. And built and studied for 9 years something called River City that was a very interesting curriculum where you went back in time to a town that had a lot of diseases and you tried to sort out what was going on. And then in 2005, I began work with what now is called mixed reality. This was augmented reality. Interestingly enough, in terms of astrophysics, we had a kind of a game we created called Alien Contact, where it turns out that aliens had landed at your middle school, but you were the only person who could see them through your mobile device. And it was a math and English curriculum. We looked at what was hard in math and English. In English, it turned out to be Greek and Latin roots. Well, that was easy because it turns out the aliens were last on Earth 3,000 years ago. So their language and talking to people was a mixture of Greek and Latin and, English. And so the kids were excited because they were learning alien rather than learning Greek and Latin roots. I mean, this is an example of using the technology for design. So I've been doing this stuff for a while and have a healthy skepticism about a lot of the claims that are made that it's magic because, of course, it isn't magic and neither is any other technology. There's a continuum now from full sensory immersion with a head-mounted display and computerized clothing, or a cave with 3 walls and a ceiling or a floor, all the way down to my new colleague Bertrand Schneider's work in tangible interfaces, where you have a lot of physical artifacts, but there are digital overlays superimposed on those. And of course, a lot of things in between. I remember 10 years ago doing talks about social media, and I had a slide like this, and I said, look, there's about 11 social media that fall along this distribution. Well, of course, now there's thousands and thousands and thousands of social media. And I suspect 10 years from now, there will be a very rich array of different tools. So if you think of a carpenter with a wrench and a screwdriver and a hammer and a saw, and you pick the tool that's right for the job, I think that both social media and immersive environments are very rich kinds of technologies that can have a lot of variants that are good for particular sorts of jobs. So that's the general part of the talk. Why, as a designer, am I so interested in virtual and mixed realities? It's because of situated learning. It's because of deeper learning. It's because of they're in classrooms. So we have, over time, kind of created a little eco-empire with EcoMove, EcoMobile, EcoXBT, EcoMod. I have a proposal in called EcoLens. We will see what happens to it. I'm sending something to Harvard called EcoShift. It turns out there's an unbelievable number of things that you can preface with the word eco, so I'm not worried about running out anytime soon. And what I want to do is give you a very light overview across these to talk about cross-cutting design themes. And the websites have a lot more information. We've published a lot on the first 2. EcoXBT, as you'll hear, is starting it's in the middle of its 3rd year, and EcoMod is in its 1st year. So the first thing was EcoMove, and the concept was if you gave students a virtual ecosystem in their classroom in the middle of the winter where they could be ecosystem scientists in the middle of the summer, and you designed it all to try to accomplish these goals of deeper learning that I waved my hand about, how well would this do? So I'm going to show you part of an EcoMove video, and if you've seen it before, try to look at it through the design lens of the themes that I came up with.
EcoMove is an exciting new curriculum research project at the Harvard Graduate School of Education that uses immersive virtual environments to teach
Yes, I will.
about ecosystems and causal patterns. It includes 2 computer-based modules.
I'm not used to a Mac.
Within a 4-week inquiry-based ecosystems curriculum. Here we are in the pond module.
I know how to make that
You can
full
walk around
screen.
the pond and see all the different plants and animals, like these ducks.
There we go.
The The camera tool lets us take pictures, and saving the photo displays
there's a
a
good
virtual
idea.
field guide with information about each of the organisms we find. We can also walk under the water to see the species living there.
All right, I'm going to start it over. So let me go back
And using a virtual
to
microsubmarine,
here.
we can shrink down and see.
There we go. Okay, sorry about that. We will try again.
EcoMove is an exciting new curriculum research project at the Harvard Graduate School of Education that uses immersive virtual environments to teach middle school students about ecosystems and causal patterns. It includes 2 computer-based modules, Pond and Forest, within a 4-week inquiry-based ecosystems curriculum. Here we are in the pond module. We can walk around the pond and see all the different plants and animals, like these ducks. The camera tool lets us take pictures, and saving the photo displays a virtual field guide with information about each of the organisms we find. We can also walk under the water to see the species living there. And using a virtual microsubmarine, we can shrink down and see the microscopic life in the pond at different levels of magnification.
This gives students a profound respect for why you don't drink pond water.
The environment around the pond includes features like a golf course, roads, and houses. Following this runoff pipe leads us to a drainage ditch near a new housing development, where we meet a landscaper putting down fertilizer. Throughout the environment, on different days, we meet virtual characters like Manny, who may provide useful information. Back at the pond, the water measurement tools let us take various measurements of the water in the pond, such as phosphates and turbidity. Students can collect weather and population data as well. The calendar tool lets us travel through time in order to see how the pond has changed on different days. Here, it's raining. When we walk under the water, we can see how cloudy the water is. The turbidity is higher, and we can also take another measurement. The data view lets us see and compare data we've collected. The atom tracker tool lets us see what happens to atoms in the ecosystem over time. We can find and track 3 atoms: carbon, phosphorus, and oxygen. On each simulated day, we can find the atom tracker signs and read a description of what has happened to each atom since our last visit. Here we see an oxygen atom that is part of a water molecule in the leaf of a tree. And then on our next visit, we see that through photosynthesis, the oxygen atom is being released into the air as part of an O2 molecule. As students explore different days of the pond, they discover that on July 28th, all the large fish in the pond are dead. Through the inquiry-based curriculum, students work in teams to collect and analyze data in order to figure out what killed the fish. Once the students have collected all the data, they can use the graphing tool to compare different variables to help them create concept maps that explain why the fish died. Through an exploration of the pond scenario within this immersive simulated environment, students develop a richer understanding of complex causal relationships in ecosystems.
So there's more. There's a forest environment that you can see on the internet if you're interested. So what are we trying to do here? We are, in the spirit of deeper learning, we're trying to do many things at once because that's a lot of what deeper learning is about. So we're teaching ecosystem science, and we measure that. We're teaching scientific inquiry. And in fact, we're teaching the front end of scientific inquiry, which seldom happens. Usually in inquiry, you're given the back end where an experiment is all set up for you and you're kind of cranking through it. The front end is when you're thrown into a complex situation and you have to figure out what the problem is. And then you have to make hypotheses, and then you have to figure out how to set up an experiment. And we're teaching collaborative science inquiry because there are teams of 4 students who are working together using a jigsaw pedagogy to try to disentangle what's going on in the pond environment. We're also teaching complex causality. That is Tina's field, is helping students to understand complex causality. And she and I started working together because she had hit kind of a glass ceiling using conventional instructional techniques. And we agreed that immersive environments might be a way to get past that, which it turns out is absolutely true. We try to be as authentic as possible, and we use magic sparingly, but with a purpose. So some of the magic is to remediate misconceptions, and some of the magic is to make visible things that are ordinarily invisible. So the microscopic life is very important and what killed the fish, but you don't see it at the macroscopic level. About half the time the students are in the virtual world, but the other half of the 2 weeks they're outside. They're making meaning with their team. They're making meaning with the teacher. They're using other tools like the food web that shows the energy flow through the system, which is also ordinarily invisible. The atom tracker shows the matter flow through the system, which is often invisible, and so on. So it's all set up to try to help them understand these different dimensions. And of course, from an affective perspective, we want this to be engaging. We want self-efficacy, where they think that, gee, I could do this as an ecosystem scientist. We want a growth mindset, and we want tenacity, so that when they start to flounder, they don't panic. They go through the period of productive floundering. And then at the end, we have a scientific convention, and each team of kids gets up and they talk about what they think killed the fish, and they present their evidence. And of course, the really important part of this is the evidence that they present. It's not so much getting the answer as it's understanding what the justification might be for the answer. So we have a lot of data on EcoMove and where it succeeds and where it could be better. But think of it as like a flight simulator. So if you're learning to be a pilot, the first thing that you do is you spend a lot of time in a flight simulator. But no matter how much time you spend in this flight simulator, you cannot be a pilot unless you get into an airplane. And in the same way, you do not want somebody to become an ecosystem scientist who's only been inside of modeling systems for ecosystem. In fact, I went to the Ecosystem Society of America, I think it was in 2010, and I presented some of the EcoMove work. And the first question was from somebody who got up and said, now you've invented something where kids will never have to go outdoors. What on earth are you doing? And we said, no, that is not the point. So the next thing that we did was to think about what's called transmedia narratives. So Disney is a master of the transmedia narrative. You have Beauty and the Beast, the book, Beauty and the Beast, the movie, the play on ice skates, the theme park, the game, the action figures. I mean, all these different media, each one of which contributes its own part to this very rich and complex narrative. So the entertainment industry really gets this. We often don't think enough about it in education. So we said, okay, if this is the continuum, what might we do? And we said, well, we need to go down a level because we want kids in the real world. And part of what they're going to do is to unlearn some of the misconceptions that the models create. And part of what they're going to do is see the beauty and complexity of real world ecosystems that we're never going to duplicate in some kind of virtual environment. Now, the technology for that was considerably easier. In fact, I want to highlight that this is the 41st year since the appearance of the first powerful handheld device for learning, the Little Professor calculator from Texas Instruments. One of the great tragedies of my life is I now look like the Little Professor. I really never thought I would get this old, frankly. And of course, our modern mobile devices are much more powerful than the Little Professor on a whole set of dimensions, and in fact, much more powerful than my $400,000 graphics supercomputer from 25 years ago. So we use that to create EcoMobile as both a standalone and a complement to EcoMove. So we began, again, not with the technology, but by talking to teachers. So we went to teachers who did a lot of field trips out into ecosystems, and we said, what do you struggle with? And they gave the standard kinds of answers that are part of the field trips literature. The kids don't really understand why they're there. They're all standing next to the teacher because if they wander off, they're likely to just get into trouble. The teacher is shouting at them. When you go back the next day, you have trouble remembering why you were even there, and so on. And we said, well, we think we can use mobile devices to design an augmented reality that will help kids see the world through the eyes of an ecosystem scientist, and that will also help them to stay focused when they're not standing right next to the teacher. That was our working hypothesis. And we said, if you also do EcoMove, we think there's some interesting complementarities. So I'm going to show a video that describes our work with EcoMobile, or part of a video. And remind me again how I make this. The green dot, got it. Okay, excellent.
EcoMobile is a program we've been developing for middle school students that helps them to connect what they're learning in the classroom with the real world experience. So they've been able to work in the classroom in their science class with a multi-user virtual environment where they explore a virtual pond. And they act like scientists to collect information about an ecological mystery that's happened at the virtual pond. But then now we've developed EcoMobile to allow the students to take some of the pieces that they're learning about in the classroom and learn more about them in the real world. So we've developed an augmented reality game that the students can play on smartphones using a 3G wireless network at a real pond. So as the students move around the real environment, they encounter hotspots. And at the hotspots, there is information that connects with what they were learning in the classroom. Things like what's a producer, a consumer, or a decomposer, or allows them to take measurements of the pond to test its water quality. So students have been coming out with us to the pond environment and going on field trips and using augmented reality.
Honestly, you've observed a lot of producers. I see a lot of green, and all of these plants and trees are producers. Yeah.
The kids have been very excited to use the smartphone devices, and it's amazing to see how quickly they can pick it up and use it to its full capacity. It took a very short introduction for the kids to be able to navigate with the device and to access these hotspots. And they were figuring things out and troubleshooting together. It was really fun to see them work together to solve some of the problems that they were encountering. And one student might not quite understand how something worked, and another student was right there to help them figure it out. Some of the programs they're using and the probes that they're using are very similar to what real scientists use to monitor ecosystems. And so they're getting experiences that rival what real scientists do, and they realize that, and they see things about the water quality and start to understand what this means for, we've had a lot of rain in the last few days. They're connecting the fact that the rain might affect what's happening in the pond and what's happening in their local environment. So they're starting to understand that the things that happen in the world are affecting things very close to their homes.
The higher, the more cloudy, and the lower, the less cloudy. I think it would be
0 to 20.
Yeah, I agree.
Yeah.
Yes. All right.
That was a good prediction. Now let's see if you were right.
Okay. Can you get the bucket?
Yeah.
Got it. Oh, you're gonna need to tap on that.
Did you fill it out?
Yeah, it's put up to the. Make sure it isn't lined up. All right, let's see. All right, now we're gonna turn this on. So it's channel 2, so it's the brown one. So
Why is
it's going up.
So if we didn't have these phones, the students wouldn't have a good way to access some of the additional information that connects with the classroom. Their experiences in the real world when we've gone on field trips with them before have been these one snapshot kind of activities that when they go back to the classroom, it's really hard to remember what they did or why it mattered. But now that we have the phones to connect their experiences in the classroom with the real world, we can take the phones back to the classroom and use them to help the students connect with their learning in both places.
This is awesome. We get to like learn about like the dissolved oxygen in this case, and we're answering the questions and we can test the water and yeah, it's awesome. It's much better than using a textbook because it's you're in it. You can see everything instead of just reading. And the questions are related to what you can physically do instead of just what you know from your knowledge.
So we had 5 years actually of work to build and study EcoMobile. And EcoMove and EcoMobile have both been released under a free license from Harvard, so that people can come to the website, they can download it, they can use it. And we've gotten pretty fair uptake on both, but especially on EcoMove. It's been interesting, actually. We found out quite by accident that, well, that isn't what I wanted to do, that 8,000 students in Arizona, middle school students in Arizona, were using EcoMove. And we thought, of course, that the district had people with taste and intelligence, but we also wanted to find out why. So we called them up and talked to them. And one of the first things they said was something that had never occurred to us. They said, well, there aren't any ponds in Arizona. Bingo. So, you know, if the Massachusetts Department of Education wants to fund Eco-Desert, you know, we're right there to try to help them out, right? Because, so like EcoMove, well, a couple things. First, notice that we're remediating some of the misconceptions that EcoMove creates as a model. When you collect data, you don't click on something and you always get the same reading. And the reading is invariant depending on where you click on it. They really have to get into the morass of exactly where are you measuring and what about stochastic variability in terms of wrestling with the data in EcoMobile. And we found that EcoMobile was powerful by itself for teachers who did field trips, but it also is even more powerful if you couple it with EcoMove. Now, like EcoMove, there's magic that we do in EcoMobile. So in a pond, one of the things that underlies complex causality is it's not just the stuff that's happening right around the pond on that day that's shaping what's going on. So we have what we call virtual binoculars where you can hold up your mobile device and you can see for miles and miles. You can see the whole watershed, and so you can start to see things remotely that are affecting the pond. We also started to think a lot about big data and what we could do with this rich data stream that's coming out of both EcoMove and EcoMobile. One of the things that we did to try to understand how to make it better was to put GoPro cameras on kids' heads. These are very inexpensive and they're fabulous. You can see where the student is looking. The microphone turns out to be good enough. You can pick up conversations with their team. So we have all these rich records of transcripts of what's going on. And then, of course, we also have log files. We have log files out of the virtual world that are very detailed, but we have log files out of the device as well, like where have you moved and which things have you activated on the device. And then what we want to do is use these log files to try to understand, as researchers, how do we make our designs better and what are students actually learning. But as an aspirational goal, this is the EcoLens proposal, could we analyze some of that quickly enough that we could give students feedback in real time? Could we give teachers feedback in real time? Could we even do something that games do, some games, which is to alter the environment itself in EcoMove in real time to kind of reinforce something that the student is confused about? Now, augmented reality as a form of mixed reality is going to be much, much more influential than virtual reality. Because the whole world can be augmented, potentially, and transfer is even better than it is out of a virtual setting because it's even nearer to the real world in terms of what's going on. Interestingly enough, mixed realities contradict something that educators have been saying to students for millennia. For thousands of years, we've been saying to students, you want to learn about the world? The world is complicated. The world is noisy. The world is confusing. Come to the forum with Socrates. Come to the medieval campus at Harvard. Come to the industrial era classroom. And we'll teach you about the world away from the world. And that's true up to a point. But with mixed realities, now we can say, but when you're in the world, you're going to have a device with you that knows who you are, how you like to learn, where you are, what around you is augmented for learning, who you like to learn with, and how to reach them. And another piece of this that isn't so much true with the virtual worlds, but is true with augmented realities, is that kids can design augmented realities. We could design an augmented reality. We could augment the astrophysics region, maybe for history, in about an hour. So technically, and he has this great slide that he shows, where 6 fifth graders are sitting on the ground in a circle and they're looking at their mobile device at a picture of a condor. In the middle of the circle is standing a condor, which they're ignoring, right, because they're looking at the mobile device. The whole complaint about these devices is they pull people out of the context that they're in. And the whole trick with augmented reality is putting on the device something that draws people out into the world rather than sucks them away from the world. Eric Klopfer, who's done a lot of work in augmented reality, also augmented a zoo, and he tells this story, a similar story, where the kids are at the lion's cage and the lion is roaring at them, and it's like, keep it down, I can't hear this video about lions, you know, that I'm watching. So it's tricky stuff, but it's interesting stuff. So what then? Well, from a transmedia narrative perspective, the right thing to do would have been to go up to VR. But mobile VR just wasn't practical in 2012. So we thought, well, okay, we'll put that on hold for a while and we'll go back and fix another thing about EcoMove, which is the fact that it's only part of ecosystem science. It's a purely observational environment. And when you're concluding what killed the fish, you're basing your evidence on correlation. And we know that correlation is very tricky. We're again about to enter the season where drownings have a very strong correlation with eating ice cream, for example. And of course, it's the hidden variable that mediates between those two that actually creates the causality. So we wanted to do EcoXPT, which adds authentic experimentation to ecosystem science, to EcoMove. Now, interestingly enough, when the proposal was reviewed, a lot of the reviewers didn't understand the epistemology of ecosystem science, because we tend to think of, don't do that in an ecosystem, and you also don't divide a pond in half typically and do something on one side and something on the other side. It's a much more complex and interesting epistemology. So as you know, as you may know, NSF has these video showcases, and we finished a couple weeks ago a 3-minute video for that on EcoMobile. This is not the world premiere, but it's only the 3rd time that it's been shown, so you're a privileged audience in that respect. And it illustrates quickly some of the things that we've added that we're now studying.
Experimentation is an important practice for the development of science understanding, but it can be hard to do classroom experiments to learn about ecosystems because ecosystems are complex systems in which processes are often hard to see and can take place over large scales of space and time. Immersive virtual environments can help students learn about ecosystems by situating student inquiry in a realistic context. EcoXPT is an inquiry-based middle school ecosystem science curriculum that is designed to support students in doing experimentation. It's based on an earlier immersive world called EcoMove, in which students investigate a virtual pond to figure out why all of the large fish in the pond have died. Students make observations, collect data over time, and talk to characters in the world. But in EcoXPT, they can also conduct a variety of experiments. The kinds of experiments that real ecosystem scientists do. EcoXPT includes 6 kinds of experiments and tools for going deeper into the causal relationships in the system. They include strategies to guide students while they investigate the world. These thinking moves are introduced through short videos and posters.
Let me show you the first thinking move that will be helpful. Scientists call it deep seeing. When I'm practicing deep seeing, I look closely.
Design-based research with EcoXPT looked at how students interact with the new experimental tools. For example, these students are adding chemical tracers to bags of fertilizer in order to see how the spatial layout and topography of the pond affect fertilizer runoff when it rains. The concept map tool allows students to construct a map
which is consumed by all three of the fish. And the fish,
Over the next year, we are conducting research studies of the full EcoXPT curriculum to see how it might enhance student abilities to develop sophisticated and accurate mental models for difficult science concepts, and to increase their engagement and understanding of forms of inquiry in science.
So we are optimistic about EcoXPT, but of course we need to look at what the actual research results are. Tina is out in the schools as we speak with our first implementation of EcoXPT, and we're excited to see what we've gotten right, and again, where there might be problems or issues that we need to be thinking through. But it's been fun to think about how to implement in a flight simulator these different kinds of ecosystems tools. And of course, we couldn't have really built EcoXPT without years of experience with EcoMove, because these tools are tuned to the kinds of misconceptions that students exhibit. So again, we're really focused not so much on just trying to simulate reality as we are to create a powerful learning experience by drawing on these different aspects of virtual environments. So here we are in 2017, and now mobile VR is possible. So now we're going back to the transmedia narrative. Harvard has an agreement with a Chinese gaming company that also does education called NetDragon Websoft. They are building Ecoverse, which is going to be the blended VR version of EcoMove. You wouldn't want to be in VR all the time. The working hypothesis is that sometimes being fully immersed with all your senses is more powerful, but only some of the time. So for example, topography is very important in watersheds. And you get a sense of topography by watching your avatar go up and down things. But if you put on a head-mounted display and you were going up and down things, our hypothesis is that you'll have a more powerful sense of topography. Again, once it's built, we'll try to get some money. We'll see if we can do some comparisons. We'll figure out whether or not that's actually true. So the last thing I want to talk about, and then we can throw it open to talk about whatever you want to talk about, is EcoMod, which is our latest project. It started last September. It's a STEM plus C proposal, so now we're adding in computational thinking and some amount of coding. We also, frankly, we're getting kind of bored with middle school, so we said, let's do third grade. And in the proposal, we claimed that third graders could actually do fifth or sixth grade work if you supported them properly, which I definitely believe. And in fact, our third graders then, when they hit EcoMove and EcoMobile, could maybe do high school level work. And then you see how the progression might go. So maybe in the long run, we'll be able to test some of those theories, but right now we're having a lot of fun designing EcoMod. So what are we doing with EcoMod? Well, we're creating a new ecosystem called Eco Island, tentatively, that has a lot of different niches that are dramatically different from one another. So there's a rocky shoreline with one set of niches and habitats. There's a salt marsh with another set of habitats and niches. There's a meadow, and there's a highland forest. So the island is something like this in tentative form. And there are islands that have more or less these niches connected with them, maybe not in this exact topography. And in phase one of EcoMod, we want our third graders to do what they do in EcoMove. They're going to wander around in the ecosystem. They're going to look at the organisms. They're going to look at the habitats, and they're going to try to draw some conclusions about why organisms are in some habitats and not in other habitats, and how organisms interact with each other. This is 3rd, 4th, 5th, 6th grade curriculum in the next generation science standards. But then in phase 2, we're going to take them outside of the ecosystem, and we're going to give them a custom computational modeling tool. This is not the tool, but this is an open source computational modeling tool for elementary school students that we're looking at the possibility of modifying. And they're going to create their own organism. So they're going to say, I'm going to create an organism that somewhere in this ecosystem can live, or maybe several places in this ecosystem it can live. And they're going to code what it eats and what eats it and where it nests and what it competes with. We're still sorting out just how complicated we can make this for students at this developmental level. And then in phase 3, and this is the part that we think is particularly cool, they're going to release a population of their organisms into the ecosystem. And they're going to see what happens to it. And then they're going to iterate, because of course they will have gotten some things wrong. So they're going to improve their organisms over time. In a minute, I'm just about done, and then you can ask. So this is the game plan at this point. You know, we're in pilots with schools trying to understand what kinds of interfaces kids can deal with, which is not a big problem because of gaming, how complicated their thinking about ecosystems can be, what we can and can't expect in terms of computational thinking and modeling, and how much we can attempt to convey. But it's an exciting direction for us that we think, again, is looking at immersion, but now even more powerfully being able to shape the immersed environment and conduct a whole different kind of experiment than EcoXPT supports. So that's the design theme that runs through this. And our EcoLearn website has lots of details. But I want to close by talking about what Phil asked, so formal learning. So they struggle. They struggle to transform what they're doing. And we know the teachers teach as they're taught. So one of the things that we do in our professional development, of course, is we put teachers into EcoMove or EcoXPT. And we teach them not as if they were in middle school, but we teach them as if they were ecosystem scientists learning these roles, so that we model for them the kind of things that we'd like them to do with students. For example, answering a question with a question rather than answering a question with an answer. In the long run, we also know that it's really networks of teachers who are implementing together that are going to be the most powerful form of professional development. And an interesting thing about immersive virtual worlds is that you can be co-located in the immersive virtual world even if you're 12,000 miles apart. It doesn't fix the time zone problem, but it does fix the geography problem, and that's potentially very powerful for professional development. But the biggest thing I want to say about professional development is that this is a problem with unlearning more than it's a problem with learning. What's unlearning? Well, you may not know it to look at me, but there was a time in my life that I was extremely thin. And I could eat anything that I wanted, and I stayed thin. And so, of course, I did. Well, then, the tragedy of time, I got older, my metabolism slowed down, and my eating habits did not follow automatically. And so I have spent a huge amount of time trying to unlearn those eating habits to cope with the new reality. And what we know about unlearning is that it's much harder than learning, and that it's emotional and social as well as intellectual. So the successful weight loss programs all involve, peer cohorts reinforcing one another and talking about how to make that happen. And I think any kind of transformative educational innovation or disruptive educational innovation involves substantial amounts of unlearning, and that we have to build that into the professional development environment, or we're not going to succeed. That's a whole nother talk, but I think that immersive learning can support unlearning as well as it can support learning. And so there's some interesting frontiers there to explore. So with that, I've left at least 10 minutes in the formal time for whatever you want to talk about, and thank you for listening so attentively to this.
So we'll have questions until the pizza comes, and then we'll break for pizza, and then we'll have more questions while people eat their pizza.
Wonderful.
Okay.
Yes.
So I had two different questions, but the first question involved, so you've got the teachers in Arizona who are downloading and using Immersion. So what kind of PD is happening for a broader scale? If you can't go to Arizona and work with all of these teachers in
That's
the
right.
workshop, so how are you supporting that?
We're not. We're not. So this is, if you will, a naturalistic experiment in how much PD matters. And of course, it's not a true experiment because these are self-selected teachers who are implementing this curriculum because they feel it resonates with where they want to go. So they're not typical teachers in that sense. We just don't have any way of really studying the outcomes other than to ask if they're pleased and if they're persisting with using it year after year. What we distribute is, in fact, not the log file version because we can't support on servers all of that, and we wouldn't know what to do with the data if we had it. It's an offline version that people can use that's less powerful, but it's still adequate to do the kinds of things a typical teacher would want to do. So that's research that's kind of waiting to happen to understand, first for teachers who volunteer, how much they're losing by not having at least some professional development, and then of course for more typical teachers, the broader population, what would happen if somebody said you will use this software, which is happening in that one district. Yeah.
Let's introduce ourselves too, so Chris knows who you are.
I'm Pat Professor. I work with Alyssa Goodman and folks in the science department on the Worldwide Telescope project.
Okay.
Talked to some of by Skype.
Right.
So my other question was just about the eco-mod, the third graders that are designing the organisms. When they go into the environment, are they just interacting with a standard thing that's already there, or are they interacting with each other's organisms that they've designed?
That remains to be seen. So what you're hearing me describe is all in the future. It's not in the present. What we have at the moment is, as pilots, is sort of paper-based mock-ups of different kinds of things where we're trying to understand what kids can and can't do. My instinct is that at third grade level, hopefully we'll be able to support kids understanding how their organism, which is like an invasive species, if you will, is going to interact with the organisms that are already authentic and part of the natural environment. I think it's going to be a bridge too far to try to understand, when you populate things with a whole bunch of invasive species, how they interact. But again, part of the magic of virtual worlds is that two kids can be sitting right next to one another and they can each release organisms into the environment, and we can determine what appears and what doesn't appear and what interacts and doesn't interact. So we can control some of that complexity.
That sounds really fun.
Yeah.
I'm a second grader. I think really nice.
Yes.
To follow up on Pat's first question, so you have this community in Arizona.
Right.
And as an aside, I'm surprised you didn't implement a desert environment in to service that function. But anyway,
Right.
you can consider that as a control. Are you even going to be doing like pre and post to see if there's content, since you're building a mastery, even though on a distance, these facilitators of this, they're persisting and continuing to use your product.
Right. Well,
So it's sort of like a
Yeah.
control to have to figure out, is this making an impact? Are they getting content?
Right.
Will they do better in a standardized test? And how are they doing that without any intervention?
right. So we would love to do that work, but we have no practical way of doing it for a couple of reasons. One is that we don't have a funding source. Another is that our instinct about advancing the field is to keep doing demonstrations of new concepts. And you can see that as we done this progression. And a third is that we're just stretched really thin. I mean, it's amazing to me that we've actually been able to build what we have been able to build with the size of the team that we have. So we would love, partners or doctoral students looking for dissertations or anybody to engage in that kind of analysis, but we personally don't plan to do it, even though we think it would be very valuable. What we are finding is that for the teachers and the districts who were choosing to use the software, the lack of formal professional development doesn't seem to be too big a deal, but that's probably because they're already doing some amount of inquiry in classrooms. Now, what may be an interesting test for that is I'm negotiating with the Chinese government because I'd really like to see millions of students using this stuff, and it's not going to happen in this country. And China's educational system has a much more wrenching, I mean, if you want to talk about an incredible divergence between what they do instructionally and what deeper learning is, it's night and day. That will be, if it happens, a very interesting test of whether any amount of professional development can really help a lot of those teachers to do the kind of unlearning that's going to be required to do deeper learning in their classrooms. I think that's a very interesting opportunity that we probably can get funding for.
I have a question. You talked about misconceptions. Could you give an example of a misconception, ecological misconception that kids have for which use of a tool helps
Sure.
remediate it?
Sure. So 3 of the kinds of misconceptions that Tina has documented in her work, because before virtual environments and my team appeared on the scene, she was doing a lot of work, 10 years of work, using ecosystems as one kind of complex causality, and in fact working at the elementary school and the middle school level. So kids have 3 fundamental kinds of misconceptions about ecosystems that are all quite understandable. They're the same as adults, naive adults have. One of them is that the things that you see must be the causes. So you can't see the flow of matter, you can't see the flow of energy, you can't see the microscopic organisms. And so you construct these narratives of linear causality that are based only on what you can see, rather than complex causality that's based on all these unseen things. A second misconception is that things, when the fish die, it must be something that happened right around the pond. In other words, the idea of remote causation across large spatial scales is not something that kids typically get. And that's why both in EcoMove and EcoMobile, we have them go across distance, and they use things like tracers and EcoXPT, and they begin to see the whole watershed actually is affecting. And the third thing is that when the fish die, it must be something that happened in time within that day. Somebody came and poisoned the water or something, as opposed to the fact that the eutrophication scenario actually develops over a period of several weeks, and it's triggered by Manny way up on the hill fertilizing the lawns so that they can sell the houses. And then there's a very complex series of events, kind of the perfect storm in terms of killing the fish that takes place. So those are 3 fundamental kinds of things that in the flight simulator we can create, and then we can kind of show what's going on. And especially in EcoXPT, they can start to do experiments where they actually control the situation, and now they're not just making correlational inferences.
Okay, is the pizza ready here?
Pizza's here.
Okay, I think we should grab the pizza.
Yes, I don't want to compete with pizza.
And
So
then we'll continue the question.
yeah, I will hang around.